Hey guys, this will be the last part of the practice final for algebra, questions 31 through 40. Just so you know, I did post just a straight up answer key online, and so when I'm writing with the mouse here, it may be a little, if you're just looking for an answer, especially if it's something that's kind of hard to read, and a lot of times with the graphing, it may be easier just to look at the answer key. And I posted that up on the Google Classroom. Okay, so question number 31. Here we go. These are pretty challenging problems because this is our first chapter that we did. When you have fractions that we're adding together, we can't cross multiply. So we have to get a common denominator and then solve that way. First step would be to factor this quadratic. Two numbers that multiply and give you -6 and add and give you -5. So it's going to be x minus 6, x plus 1. And if you notice, this one has an x plus 1 in it. This one has a x minus 6 in it. So basically what we need to do, I don't want to write the whole thing back out again, but we're going to have to multiply the -1 over x plus 1 by x minus 6 over x minus 6. And this equation here, multiply it by x plus 1 over x plus 1. And then our denominator on all three terms is going to be x minus 6, x plus 1. So we're going to multiply this by x plus 1. And that's, I know, hard to read. And then the denominator, I'm going to multiply it by x plus 1 over x plus 1. So I'm multiplying by 1. And then this one I'm going to multiply by x minus 6. And then once again, I'm multiplying it by 1 because I'm multiplying it by x minus 6 over x minus 6. Then all of the denominators are the same. And so once all the denominators are the same, and once again, this might be easier to see from my answer key because I'm not going to write this all out again. I can get rid of all the denominators. And basically what I'm doing is I'm multiplying both sides of the equation, both sides of this equation, by the denominator, and that gets rid of the denominator in all three terms. And so what we're left with is 7 plus x plus 1 times x plus 1 and then when we do end up with a solution to this, it says check for extraneous values. So if we end up with a +6 or a -1, it might look like a solution, but it's actually not a solution because we can't divide by 0. And that's going to equal -1 times x minus 6. And now we should just be able to solve. Unfortunately, we're going to end up with a quadratic and have to set it equal to 0. We didn't do too many of these. This is 7 plus x plus 1 times x plus 1 is x to the second plus 1x plus 1x, which is plus 2x, and then plus 1 times 1. That's foiling. X times x, x times 1, 1 times x, and 1 times 1. Gives me x squared plus 2x plus 1 equals a -x plus 6. And to solve with this quadratic, we're going to put all of the terms on the one side and set it equal to 0. So I'm going to have x squared plus, I'm going to add 1x to both sides. That's going to get rid of this x, and I'm going to end up with 3x. And then I have 7 plus 1 is 8, and then I have to subtract 6 from both sides. So I'm going to have 8 minus 6. So I'm going to have plus 2. And that's going to equal 0. And I'm kind of skipping a step there. I normally do that in a couple of steps. But I'm basically combining all the like terms. So I'm combining all the x squareds. There's only one of them. Combining these two x's, and I'm combining the single digits and setting it equal to 0. Now this factors into x plus 1 times x plus 2. If you come out of this class and you can factor a quadratic like this, you're doing okay. And that's two numbers that multiply and give me 2 and add up to 3. So 2 and 1 add up to 3. And now we're looking at setting both of these two things equal to 0. So if x equals -1 or x equals -2, either one of those will be a solution, because if it's -1, I'm going to have 0 times 1, and that's going to be 0. And the other way, it's going to be 0 times -1, and so it's going to be 0. So 0 times anything is 0. These two things will make these two factors equal to 0. And I mentioned before, it can't equal -1. So this one's not a solution. So our only answer is x equals -2. Well, that's fun. So we could cross multiply here, but since we have the same denominators on both sides, we can just set this equal to 8 equals x plus 2 and have a solution for this equation. And subtract 2 from both sides, so x equals 6. So if you think about x equaling 6, we have 6 minus a. And we can't let that equal 0. So a cannot equal 6. Any other number? Well, x equals 6. Any other number for a will be fine. So if we have x 8 over 8, because x is equal to 6, 8 over 8, and x minus any number, pick a number, 10, x, 6 minus 10, 6 minus 10, 8 over 4 over 8 over 4. However you want to look at it, any number other than a equal to 6 will work. So a can't equal 6. Question number 33. Graph of the parent functions, because they're going to ask a question on the final of what type of function is this. You can plug the absolute value is kind of a hard one to put in the calculator. It looks like this, or you can go y. You have to look under the math symbol. There's a couple ways to get there actually, but if you go y equals math, and it's just a number under the number ABS, that's absolute value. See, it's got the double line, and then x. And if I graph that, it looks like a V. That's the parent function, and you can stretch and transform it and do different things with it. Linear is just like y equals x. That'd be a parent function, and that's a line that goes like this. There should be little arrows on the end. Quadratic is y equals x squared. That's a parabola. Well, that's not a very good one. X to the second. As I mentioned before, sometimes working with this mouse is kind of hard. 1, 1, at 2 you're at 4, at 3 you're at 9. And that -1, it's the same thing, because and it's symmetrical across the so there's our it's a curve up, and it goes up fairly steep. You've seen quite a few of these. Square root, and you can plug these in your calculator. Y equals square root. Sometimes they're kind of hard to see. second square root of x. And I hit the trace button, then you can get some points. And if you notice that 0, 0, 0, because the square root of 0, so this is y equals square root of x. If you hit your trace button, square root of 1 is 1. Square root of 4 is 2. So it goes up, but it goes up fairly slowly. At 9, it's 3. And you can't put in a negative number, negative 1. It's not defined. Because you're taking the square root of a negative number. So at 0, 0, graph starts at 0, 1, at 4 you're at 2, at 9 you're at 3. So it curves up, and then it really curves up slowly. Domain and range. So here's an absolute value function, and it's an absolute value that's gotten shifted 2 to the left. Negative 2 makes that 0. So it's gotten shifted 2 from the original parent function. The parent function looks like this, a v that's up there. The negative flips it over the x-axis, so then it would be down like this, and then we go up 5. 1, 2, 3, 4, 5, so it goes up to here. And there's our two, it looks like a v. Domain is, you can put in any real number for this. You can have the absolute value of 0 or a negative number. Domain is all real numbers, and the range is whatever y can be. And y is going to go down to infinity, but it will never go up above 5, because this part of the graph here is the lowest it can be, because absolute value turns things positive. The lowest it can be is, or the highest it can be because it's negative, is when this thing is 0, and then we're adding 5. So the range is, it's going to always be below. Y is less than or equal to 5. 33, 34, all right, 35. What are the same with the graphs of the absolute value and square root functions? Well, if we look back at, oh, I see, because this one it says what, I forget exactly how they word it on the final, but you want to be familiar with these two graphs. Here's your absolute value. It looks like a V. And here's your square root. So the 0.11 is on both of these graphs. Absolute value of 1 is 1, and negative 1 is 1. So it's, they're going to be positive numbers for square root. Any other number now, the absolute value function is going to go 1, 1. It's going to go like this, and then it's going to go up. So that's the only point it's going to contain in common. The domain is all real numbers for absolute value, and it's only positive numbers for square root, so the domain is not the same. The range is actually the same, because the range is y is greater than or equal to 0 for absolute value, and the range is y is going to be greater than or equal to 0 for the range too. So the range is actually the same. Those are the same, and then it contains the 0.11 and also the 0.00. Absolute value of 0 is 0, and the square root of 0 is 0. And why I put this one in as a practice test, it asks you what kind of a function is a person's height. They may have gotten rid of this question, but if they did, think of it starting at 0 for height at 0, and then at, like at 1 you're a foot or so high, and then it you kind of grow, but you kind of level out. So it grows like this. And so the person's height from 0 to 15 years is really looks a lot like the absolute value or the square root function. but dumb question, because at 0, are you really 0 high? When you're born, you're usually about 2 feet high, and then this looks more linear. So it was a bad question. All right, question number 37. A few more here. Given the equation, so here, this is the absolute value. So just a reminder, because we didn't talk too much about absolute values in this class, but all the absolute value does is it takes negative numbers and turns them into positive. So absolute value of positive numbers, it's just, you don't need the absolute value, because absolute value of 5 is 5, absolute value of 10 is 10, but absolute value of negative 5 is positive 5. So we take this graph, but the transformation would work the same as it does for any other function, like a quadratic or square root or anything. And so we're going to shift it across the x-axis. So we're going to take that absolute value graph, and when we shift it, that's how we flip it over the x-axis. When we want to shift it 5 units up, we go plus 5. That's going to shift it up. So g of x is going to flip it and then lift it up 5. Just a reminder, if it's going to be shifted left or right, you would, if we just take the absolute value graph and we want to shift it 5 units to the right, you would take the absolute value of x minus 5. That would shift absolute value to 5 to the right. Positive 5 makes that 0. All right. So g of x is the transformation. So we start with f of x, and here's our new graph, g of x. And they have some kind of similar shape like that on the final. So if you just take one of these points, we're moving this graph 2 to the left. So we're going 2 left, and we are going up 4, from f of x to g of x. So then 1, 2, 3, 4 up. So here's how you write that. G of x, our new graph, is equal to f of x, but it's not f of x because we're going 2 to the left. So it's f of x minus, so plus, we'll move it to the left, plus 2. That's going to take our graph and move it left 2. And then we're going to go up 4, so then we add 4 afterwards. Sort of difficult notation, but the idea is the same. A plus moves it to the left, what you do directly to the x. When you add a number at the end of it, it's going to raise it up. All right, 2 more questions. Yeah, I graphed, and this one might be another one where you want to look at the answer key that I posted. But let's say you had a quadratic that was kind of like this. This is my f of x, and here's my x-intercepts. Well, if I take negative f of x, I'm going to do a different color. That's going to flip this thing over the x-axis. So it's going to go like, let's see if I can. I'll copy that and paste it here. Okay, I'm trying to get the same graph. Okay, I just copied that without making you watch me try to do it. Negative f of x is going to flip it over the x-axis. So let's go red. And so this graph is going to flip over, and our x-intercepts, remember this is your x graph, our x-intercepts are at the same spot. So this one will have the same x-intercepts. F of a negative x, we didn't really do transformations like that, but it flips it over the y-axis. So this graph comes over here. And it's obviously going to have different x-intercepts, so this one won't be. X plus 1, that's going to shift it 1 unit to the left, so it's going to be like this. And once again, not the same x-intercepts. And f of x plus 1, so everything gets lifted up 1. Well, it's going to cross at a little bit different point. If you think about a graph that's right on the x-axis, like the parent function, even this one, when you go up 1, now this one doesn't even cross the x-axis. So this one isn't 1. This is the only graph that's going to keep the same x-intercepts. And the last one more transformation problem. So f of t, here's our graph of f of t. And so in other words, we set our thermostat for the first 4 hours, like whatever, midnight till whatever that is. Maybe it's 6 in the morning at 65 degrees. Then we have it warm up when we get up in the morning to 72 and keep it at 72 until whatever time, 10 o'clock at night, and then we have it go back down to being cold again. So what we want to do is we want to, I don't know, change our clocks. So we want to do this same graph and move it 4 hours later. So we want to go 4 to the right and 2 degrees colder. So we want to go down 2. So 4 right and down 2. And if I just think about my like 1 point here, I'm going to take that point and go, let's say I'm at 6, that's going to go to about 10. And then we're going to go down to from 60, a little over 64 to here. That's going to be that bend right there. And this point's going to go down, right 4, a little bit over, and then down 2. So our graph's going to go like this, something like this. And it'll start 4 hours later. Right equation, so g of t, basically we want to do the same thing we did on just problem before, where we have g of t is equal to f of t, but we take f of t and we move it 4 to the right. So that's going to be t minus 4. That's going to move it 4 to the right. And then we're going to make it 2 degrees colder, so we're going to subtract 2. So it's f of t minus 4 minus 2. And that should do it. Once again, look at the answer key and maybe you can be a little more clear. And then ask me questions if you got them. Good luck. Bye now.